Good morning, respected teachers. I am Namita A with the USN of 1MS10CS071. I am doing the seminar presentation online. The topic for my seminar is case-based reasoning. The PPT has already been done, so I'm going to give a brief explanation how the case-based reasoning systems are related with the future internet, collaborative filtering. We have some similarities with the collaborative filtering, which will be explained later. We also see how the cycle works with different components, which has 4 steps. We'll be seeing that later on. And we also have different types of CBR, which I'll be explaining and showing later. Let's begin with the definition for the case-based reasoning. Coming to the definition, it is a process of solving new problems based on the solutions of similar past problems. By this we mean that, for example, we have a case. We solve the case. If we solve the case, we have a solution to it regarding different methods or how we solve it. We store the solution, and once there is a new case which is arising in the future, which is similar to that which had already been solved before, we can use the similar techniques or methods to come to a solution for the same problem. Case-based reasoning is also known as reasoning by remembering. It is also known as a starting point for new reasoning. Case-based reasoning is a well-established research field that involves the investigation of theoretical foundations, system development and practical application, building of experience-based solving. We have some examples which show the case-based reasoning definition. In an everyday example, a simple example is an auto mechanic who fixes an engine by recalling another car that exhibited similar symptoms. So here the mechanic is using the techniques to solve the problem of a previously solved case. So he uses those techniques to solve the new problem. So another example is a lawyer who advocates a particular outcome in a trial based on legal precedents, or a judge who creates case law. Another simple example here is an engineer copying work elements of the nature. The work elements of the nature here act as a database, that is, treating nature as a database of solutions to the problem. So the database solutions to problems, we are using those as the work elements. Coming to the problem solver, it is necessary to explain how case-based reasoning also works as a problem solver. We see two things here, which is a case and the case base. Explaining the case in the case base, case is nothing but a previously made and stored experienced item. So it's previously made and it's an item which is stored. Coming to the case base, it is the core of every case. Core of every case, which we can also say as collection of cases. So in the next we see that a case-based problem solver solves new problems primarily by reuse of solutions from the cases in the case base. As told previously, we are reusing the solutions. For this purpose, one of the several relevant cases are selected. So we can select one of the cases. There might be different similar cases. So we select the relevant case from the other cases. One of the core assumptions behind CBR is that similar problems will have similar solutions, as told previously. So once similar cases are selected, the solutions from the case are adapted to become the solution of the current problem. When a new solution to the new problem is found, a new experience is made, which can be stored in the case base to increase its competence, thus implementing a learning behavior. So we might solve many cases, but we cannot select any random solution from those cases. So we see that there is a behavior that we can choose the best. So through the experience we can see which is the best solution and select that new solution from it. Now coming to the types of CBR. In CBR, we have different types that differ significantly from one another concerning cases, representation, and reasoning. So we have three types here: a structural, textual, and conversational. Coming to the structural, it's nothing but a common structured vocabulary. In textual, we see that the cases are represented in the form of free text, like strings. In conversational, it is a case is represented through a list of questions that varies from one case to another. So a same case might not have same set of questions. It might have varying questions. Knowledge is a contained in customer agent conversations. So coming to the CBR cycle, we have different phases in the CBR cycle, which we'll be seeing soon. Despite the many different appearances of CBR systems, the essentials of CBR surprisingly simple and uniform process models. They're simple and they go through a process which is uniform and will follow those 4 phases which are going to be mentioned. The CBR cycle was proposed by Amott and Plaza. The CBR cycle consists of 4 sequence steps. First we see is we have a problem. The first step is to retrieve. So when we have a problem, we take it as a new case. That new case has to be checked. Once we check the new case, we get to know what the knowledge of the problem is. So we have to bring back all the problems which that case has, and we have to retrieve the case. So and we should also check the previous cases if there are similar problems which were occurred, like the new problem that has been seen. So after the retrieval, we have the reuse. So reuse is nothing but reusing the retrieved solution. That can be quite simple if the solution is returned unchanged. So when we retrieve, if the solution is returned unchanged, then we can go to the reuse phase. So the reuse phase will also check the solved cases. The next we have a suggested solution. From the previously solved cases, we check the solutions and when we use, after the reuse step, we see if the suggested solution is suiting the particular situation of the problem. Next we have revise. Revise does nothing but it is like the feedback. Feedback nothing but can be given in the form of correctness rating of a result, or it can even be done manually. It can be rated or it can be done manually. So revise helps us to see if the case has to be repaired, or if there are changes to be made, or any other alterations. So after doing the revise phase, we see to that it is confirmed. The solution will be confirmed accordingly. Then we retain. Retain helps us to see how well the case has been learned. So once we learn the phase, the whole case is being learned, then it goes to the previous cases and check if the solutions are similar or if there are changes to be made. So this is a newly formed solution which will be stored. So as I told, retrieve, it is one or several cases from the case base are selectively based on the model similarity. The retrieval task is defined as finding a small number of cases from the case base with the highest similarity to the query. So when we check the case base, we are going through many cases to check the similarity there. When the case base grows, the efficiency of the retrieval decreases. This is done by methods that improve retrieval efficiency. Okay, after that it was reuse. As I said, reusing a retrieved solution can be quite simple if the solution is returned unchanged as a process solution for the new problem. We also have adaptation and reuse, which is of different types here. The techniques which are used for different types is transformational adaptation and generative adaptation. Most practical CBR applications today try to avoid extensive adaptation for their benefits. We also have revise. As I said, in this phase, feedback related to the solution constructed so far is obtained. The feedback can be given in the form of correctness rating of the result or in the form of manually. The revised case or any other form of feedback enters the CBR system for its use in the subsequent retain phase. Next, we had the retain phase. As I said, it was also like the learning phase. The retain phase is the learning phase of the CBR, where adding a revised case to the case base. So we are revising the case which is being checked and being gone through, and we are adding it to the case base. Explicit competence models have been developed that enable the selective retention of cases. The revised case or any other form of feedback enters the CBR system for its use in the subsequent retain phase. Okay, now going to the CBR and the future internet. It is very important for us to check on the future internet, how it is related with the CBR, as the development of the future internet is affected with two major factors, that is the semantics and the collaboration. Okay, two most influencing developments of semantic webs. We have 2 points here. Firstly, we have the resource description framework, which is the RDF. So the resource description language has the RDF, and we also have the knowledge representation language, which is also known as OWL. So the web ontology language, which is this language is based on the RDF. XML has been used as a case representation within the case-based reasoning community. But this is done before the development of the RDF and the OWL. So we have we have the similarity, which is like, how OWF and RDF both lend themselves to be used as a case representation languages, and thus expand the possibilities of case-based reasoning within the general WWW. There are technological and methodological similarities between the ontologies and structured case-based reasoning, and there are synergies that can be reached by merging both applications. So here RDF and OWL, the synergies are reached such a state that they are merging because of their similarities that are being seen between the two. Next, coming to the collaborative filtering, we are seeing how the relationship between the CBR, which is the case-based reasoning, and the collaborative filtering is being done. The relation here is like given in forms of examples. So there is a very close relationship between the collaborative filtering and the CBR, and since there is a relationship between these two are very close, they can benefit from each other. So we have a few examples. One of the example is collaborative, we can, for the examples we are seeing how they benefit from each other. So those examples are like regarding the similarities between songs. We're taking the similarities between songs to explain how they relate to each other, and web search results. So in the similarity between songs, collaborative filtering is used to assess the similarity between songs in a CBR system, creating custom music compilations. So these compilations show us the relationship between them, how it is being shown. So another example is a community-based web search that uses the results of previous web search of similar users in order to improve the web search results. So by using the previous web search, we are improving the web search results. Okay, we have applications. There are different type of applications. So the applications here, during the past 20 years, many CBR applications have been developed, ranging from prototypical application built in research to large-scale fielded applications developed by commercial companies. So different applications are as listed here. Applications areas of CBR include help desk and customer service, recommender systems in electronic commerce, knowledge and experience management, medical applications and applications in image processing, applications in law, technical diagnosis, design, planning, applications in the computer games and music domain. Those were the applications. So coming to the criticism of the CBR, we see that critics of CBR argue that it is an approach that accepts anecdotal evidence as its main operating principle, which is nothing but like a real incident. So it should accept that the real evidence as its main operating principle without statistically relevant data for backing and implicit generalization. There is no guarantee that the generalization is correct. So there is a recent work that develops CBR within a statistical framework and formalizes case-based inference as a specific type of probabilistic inference. Thus, it becomes possible to produce case-based predictions equipped with a certain level of confidence. Okay, so as I said in the beginning, case-based reasoning is nothing but getting solutions by going through different processes, by checking previously solved problems, by reusing it, retaining it. We are going through the different cycle phases of the case-based reasoning. So coming to the conclusion, the number of CBR approaches and applications developed up to now has become quite large. There is a significant number of CBR research groups and commercial companies which develop CBR methods, software components and applications on a regular basis. So the software components here, we say we can compare it like by seeing to that the new software which is created is being improvised by looking into the previously done software, and how we can improvise on the new solution to the software which is being created. CBR is not only a technology but it is also a method, like how it is process oriented. It has different processes which it goes through for the new solution which is being formed. The combination of CBR with various other technologies within a great bandwidth of applications has become increasingly attractive for researchers as well as business professionals. So concluding, as we saw the different processes, cycles, how it is related with the collaborative filtering, how they can benefit from each other, and we also saw the applications, how wide range of applications and how the different components are being used. Case-based reasoning systems are widely used in different companies also now. As we saw the conclusion, I would like to end the seminar with a thank you.